This third lecture video on force will go through a couple of examples using Newton's second law of motion. We want to find the force needed to produce an acceleration of 6.00 feet per second squared if an object has a mass of 4.00 slugs. We will first write down all of the information we are given. The acceleration is 6.00 feet per second squared, the mass is 4.00 slugs, and we are trying to find the force F. The basic equation we will use to solve this is Newton's second law, which states that force equals mass times acceleration. Since we are trying to solve for force, the basic equation is the same as the working equation. Next, we can substitute in the data we were given, so force is equal to the mass of 4.00 slugs times the acceleration of 6.00 feet per second squared. This gives us a force of 24.0 pounds, rounded to 3 significant digits. Let's take a look at one more example of Newton's second law. Find the acceleration produced on a mass of 32.0 kilograms if a force of 625 newtons is applied. Like the last problem, we will first write down all of the data we are given. We know that the force is 625 newtons and the mass is 32.0 kilograms. In this problem, we are trying to find the acceleration A. The basic equation we will use to solve this problem is force equals mass times acceleration. In this problem, we need to rearrange the basic equation to solve for acceleration, so if we divide both sides by the mass, we are left with acceleration equals force divided by mass. Next, we can substitute to see that 625 newtons divided by 32.0 kilograms is equal to an acceleration of 16.5 meters per second squared, rounded to 3 significant digits. This concludes our examples of Newton's second law of motion.